Valence electrons. In this activity, you'll look up each symbol and write its element name, the atomic number, the number of full energy levels, and the number of valence electrons. This one is a little bit tricky. Let's make sure that we know exactly how to do it. I'm going to take you through an example so you can see how it's done. If I look up the symbol Li, I find Li right here. It's lithium. So I would write down lithium as the element name. The atomic number, as you can see, is 3. That part's easy. What isn't quite as easy is the number of full energy levels. The whole idea here is that when we talk about a full energy level, we mean that it's holding as many electrons as it can possibly hold. So let me show you an example of this. If I were looking at lithium, I know it's going to have 3 total electrons. So I'm going to draw myself an atom. Here is lithium. It's going to have a nucleus with protons and neutrons. Then its first energy level of electrons around the nucleus can hold up to 2 electrons. All right, that first energy level can only hold 2. But I know lithium has 3 electrons, so I would go ahead and give it another energy level with that 3rd electron. Now, how many of these 2 energy levels that lithium has, how many of them are full? Only this first one. The second level is not full because this second level can hold up to 8. So I do not count this second level as full, only this one. So here I would put 1 because lithium has 1 full energy level, which is this first one. Now if you'll look at the periodic table, let me go ahead and put this up here. These elements, anything in group 1, or excuse me, in period 1, such as hydrogen, can only have up to 2 electrons in its outermost energy level because the first period is representing the first energy level of electrons, and the first level can only hold 2. Let me zoom out a little bit so that we can get the entire periodic table on here. And let it focus. There we go. So, period 1 has 2 elements in it, which means that the first energy level can only hold 2 electrons. Notice period 2 has 8 elements in it, which means that that second level can hold 8 outer electrons. The third level can hold 8 electrons as well. The fourth level, 18. If I count all these, it'll be 18, and so on. So when you are trying to figure out how many full levels it is, what I want you to realize though is you don't have to sit there and draw every single one. If I look at this, I can go, okay, the first level holds 2. So if I have 2 or more electrons, then I have an energy level that's full. The second level holds 8. So once I get to this one, I have 2 in the first level, another 8 in the second level. That would get me to 10 outer electrons, excuse me, 10 total electrons, and that would give me 2 full energy levels. Fluorine only has 1 full energy level because it would have 2 in the first level and 7 in the second level. Only once I got up to 8 would that second level be full. So the easiest way to do this is, unless it's one of the noble gases, which is group 18, look at what period it's in, and the number of full energy levels will be the same as the period number before it. For example, magnesium would have 2 full energy levels. So would aluminum, so would silicon, phosphorus, sulfur, and chlorine. Once I get to argon, this energy level is now full, and so argon would have 3 full energy levels. All of these elements would also have 3 full energy levels until I get to this one, krypton, because this fills up that energy level with as many electrons as it can hold, and so krypton has 4 levels full. But all of these only have 3 all the way until I get to here because it's only full to this spot. So if I draw another example for you, I'm going to use the bottom of this paper. So if I were looking at, let's do SC, scandium, it's going to have its nucleus. The first level is going to have 2 electrons in it. Here's scandium. Sorry, I should show you where it is. It's element number 21, so it has 21 electrons. The first level holds up to 2, second level holds up to 8, third level also holds up to 8, and that gives me a total right now of 2, 8, and 8 is 18, but I know scandium has 21. So that would leave me with 3 valence electrons here. So what I'm going to do, I would put up here that it had 3 valence electrons, which is that last column, but I would put that it had 1, 2, 3 full energy levels, because these have as many as they can hold, and all I'm doing again is looking up at the period before it to determine that this has 3 full energy levels until I get all the way over here to krypton, which then, move this over, which then would have 4. So, noble gas, same number of full energy levels as the period. Before the noble gas, it has the same number of energy levels, full energy levels, as the period before it. Again, if you have questions, feel free to ask. I know that this topic is a little bit odd, but I want to make sure you understand it because there is a quiz over this information at the end of your packet.